The question is saying that what should be the distance between the object in exercise 9.23 and the magnifying glass if the virtual image of each square in the figure is to have an area of 6.25 millimeters square. Would you be able to see the squares distinctly with your eyes very close to the magnifier? So we have been given the desired the area of a square that is desired, and we have to find out the object position for the desired surface area. So we can say that a dash is 6.25 millimeter square, where a dash represents the area of the image. So we can deduce from this the length of each square. So length would be the square root of this area, which will give us 2.5 millimeter. Now we saw that in this question number 9.23, the length of each square and the width of each square was 1 millimeter. So upon magnification, it is going to be equal to 2.5 millimeter. So we see here that linear magnification is going to be V by U, which is the final length divided by initial length, that is 2.5. So we can say from here that V by U would be equal to 2.5. Now here we are desired to find this value of U. So now we have got the value of V in terms of U. We can write V equals to 2.5 U from this relation, and we know the focal length of this lens, which is 10 centimeter. So there is only one variable, that is U, to be used in the lens equation. So we can find out the value of U. Now later we have to say that we have to comment on, would you be able to see the squares distinctly with your eyes very close to the magnifier? So for this value of U, we will be able to see the squares distinctly with your eyes. Now, in order to see the squares distinctly, the minimum distance should be equal to D. So let us find out whether U is greater than D or whether U is less than D. If U is less than D, then we won't be able to see it, and if U is greater than D, then we will be able to see the squares distinctly with our eyes. So let's use the mirror equation. Let's use the lens equation to find out the value of U first. So 1 by V minus 1 by U would be equal to 1 by F. Now 1 by V in terms of U is equals to 2.5 U. Now 1 by U is as it is. Now 1 by F would be equal to 1 by 10. Now the value of U calculated is minus of 6 centimeter. That is, the object should be 6 centimeter away from the objective or the magnifier. Now here we can see that the least distance of distinct vision is 25 centimeter, and U for this desired area is minus 6 centimeter. So U is less than D. So we can't see the square distinctly. Thank you.